So in this lesson, we're going to talk about how to find the lengths of segments, the slopes of some segments or lines, and the midpoints of some segments. So we'll start by finding the length or the distance between 2 points. So I've got a grid. I've got the points -9, -6. So -9, -6 is going to be somewhere down here. We go to the left 9 from the origin, and we go down 6. And 3, 10 is to the right 3 and up 10. So what I want to do is I want to find the length of this segment. So I guess I got to take out a ruler. What units do I measure? How will I ensure that the answer that you get, the answer that your friend gets, the answer that your enemy gets, and the answers that I get are the same answer? We need that consistency. So we can't really use like inches or feet or centimeters or anything like that, because if I group all of these things together and we measure that distance, what happens when I do this? So you can see there's a special way to measure some type of a coordinate distance. And you probably don't want to say, okay, well, that's like a little bit more than 1, and that's like almost 2, and that's halfway to 3, and that's about 3. You're not going to be able to count diagonal boxes on a grid. You can't do that. But we can count a horizontal, and we can count a vertical distance. That's nice to do. Horizontally, we go over 12 boxes. Vertically, we go up 16 boxes. Now, you might be screaming, slope, rise over run. Hold on, don't do that. We want to figure out the distance, the length. So I'm thinking whenever we got to do a distance, we have to go to our friend, the Pythagorean theorem. So let's say A is 12, B is 16. I think when I do 12 squared and 16 squared and sum them, I get 400. And then I take the square root of 400. And I get that that length is 20. So this has a distance of 20 units. And the units are whatever size the squares are on our grid. This way, everybody's consistent. So the Pythagorean theorem is our friend. But what happens if we can't graph it? Well, let's imagine if we could graph it. If we think about what it might look like. So maybe the point 1534 is about there. And maybe the point like 4270 is about there. So it looks like that. And we kind of do the same thing. We want that distance there. We can still make our right triangle. But how do we figure out that length? How do we figure out that length? Well, if we want to figure out what that length would be, let's remember that horizontally, this whole distance is 42, but then I'm going to take away the 15. So this distance down here is 42 minus 15. And the same with the vertical distance, it's 70 minus 34. So now I can do a Pythagorean theorem. So I'm going to say, let's call this distance like D. So if I do my 42 minus 15, whatever that number is, and square it, that's like my A squared. And then I do 70 minus 34, that's my B value, and square it. That equals whatever my distance is squared. And I know I can just subtract 42 minus 15, but I'm getting somewhere. I even want to go one step further, because I want something where I can just type it all into my calculator in one line and get the answer. So if I take the square root of both sides, what I get then is the distance is equal to the square root of all this. Now, if we go and calculate this in our calculator, I believe that we're going to get the answer to be 45 as our distance. Check it if you don't believe me. And the reason why I took time to write it this way is because I'm trying to motivate something. What I want to motivate is there's a way that we can just generalize and find this out. So if we have 2 points like x1, y1, and another point like x2, y2, and I want to find the distance between them. If you think about what we did back here, we took the two x values, 42 and 15, and we subtracted them. That's right here. And then we squared it. So if I go here, my distance is the difference of my x's, and then I square that number. I did the same thing with my y values. Over here, I got 70 minus 34. Same thing. So I'm going to take my two y values and subtract them, square it. That gives me the lengths of the two sides of the triangle. I'm going to add them together. I'm going to take the big old square root. This baby is called the distance formula. So if you are a formula lover, you can always go and use the distance formula. If you would prefer graphing it, drawing a triangle and doing the Pythagorean theorem, by all means. I'm going to practice one with the formula. I want to determine the distance between these 2 points. So again, my distance formula. I know you're saying that's pretty hard to remember. It's not that hard to remember. It's the square root of the sum of the squares of the differences of the coordinates. Okay, let's go plug some numbers in. So I'm going to take my two x values and subtract them. Negative 3 minus 2. And I'm going to square that. I'm going to take my y values and subtract them. And I square that. So that gives me negative 5 to square and positive 5 to square. Oh, the reason why I'm writing it down so tediously like this is because I want you to make sure that you know that the square of negative 5 is positive 25. So our distance is the square root of 50. Now, if you go to a calculator and you type that in, you're going to get something like about like 7.071 and a bunch of other numbers. I'll be honest with you. I don't want a decimal as an answer. I want your answer to be radical 50. That answer is fine. Now, if you got an answer like radical 49, you better write 7. But if you get radical 50, leave it as radical 50. That's fine. So that is our distance formula. So now we get to play with another one. Completely different. We're not doing distance here. What number's halfway between 1 and 7? What's in the middle of 1 and 7? What's the average of 1 and 7? So maybe you're thinking I got to do 1 plus 7 and divide it by 2. And 4 is right in the middle. It's 3 away from those. What number's halfway between negative 6 and 8? We can do the same thing. And that's going to give us 1. And look at tricky me here. Now, which coordinate on a grid is halfway between 1, negative 6 and 7, 8? Can you tell that the x's are 1 and 7 like the problem up here? So the coordinate is going to have an x value of 4. And can you tell the y values are negative 6 and 8? So it's going to have a y value of 1. And if you even think about where this looks like on a graph, so I have the point 1, negative 6, which might be like way down here. And then the point 7, 8 might be like way up there. And if I want the midpoint of that segment, does it kind of look like it could be about there? So it might visually make sense. If not, graph those points and draw it out yourself. So we call that point the midpoint. So again, we're going to generalize it. If we're given 2 points, like x1 comma y1, we don't make that a 2, make it a 1. x1, y1, and x2, y2. We're going to say the midpoint is another point, so you got to write it as a point. Add up the x's, divide it by 2. Add up the y's, divide it by 2. So the midpoint is a point. It's the average of the coordinates. And what it does is it divides the segment into a 1-to-1 ratio, meaning that the midpoint is in the middle. It's actually the middle point. It's the same distance on both sides of it. So that's our midpoint. We love midpoint. But even more, you love slope. So remember that slope is maybe change in y over change in x. And this is the time that the order matters. I don't care which point you call x1, y1, and x2, y2. I know your algebra teachers loved to do this last year. x1, y1, x2, y2. If that helps you, do it. I love it. So our slope, you know why we use m for slope? M stands for measure. If you think about it, you can measure a length, you can measure an angle. How do you measure a line that goes off in both ways to infinity? Well, you can measure its steepness. So that's why we call slope M. How fascinating. So let's see, we're going to do 8 minus negative 4. Change in y, change in x is going to be negative 16 minus negative 3. So on top, we get positive 12. On bottom, we get negative 13. We can also write that slope if we want to by putting the negative 12 on top and the 13 on the bottom. That's okay. That just is subtracting them in a different order. Or we can just make the whole fraction negative. Either of those answers is good. The answer that you don't want to say is negative 12 over negative 13. That's bad. Don't say that. All righty. 2 other concepts here. The slopes of parallel lines are equal. Should make sense. If those 2 lines are parallel, doesn't look like they have the same steepness. Should make sense to you. Now, the new one, the slopes of perpendicular lines, are things that we call opposite reciprocals. So remember, opposite is change the sign. So negative goes to positive, positive goes to negative. Reciprocal is flip the fraction over. So for example, if you have a slope that's equal to, say, 3 over 4, the opposite reciprocal slope is going to be the flip the fraction over and negate it. So you get 4 over 3. So our last part of the day is determining whether segment AB and segment CD are parallel, meaning same slope, perpendicular, meaning opposite reciprocal slope, or neither, meaning neither. Well, let's find some slopes. The slope of segment AB, change in y over change in x, 6 minus 2 over 10 minus 4 is equal to 4 over 6. And I always like to try to reduce my fractions, because sometimes you might not see things until you reduce them. So I'm hoping the answer is 2/3, because then they're parallel. Hoping the answer is negative 3/2, because then they're perpendicular. So let's see, for change in y for CD, 11 minus 5, 3 minus negative 1. That's going to be 6 over 4, which is 3 over 2. Guess what? They're reciprocals, but they're not negative reciprocals. These slopes are neither parallel nor perpendicular. They're just 2 segments. So that's a brief introduction into our coordinate geometry of our distance formula, midpoint formula, and slope formula, and how it's used.